Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this particular question belongs to paper 9709/43 for the session May June 25. We are going to solve the last of all questions of this paper, which is question number 7, and it is based on kinematics. Let's read the question. It says a particle x moves in a straight line, the displacement of x from O at time t second after leaving O is s meter, where s is equal to zero point 0.3 t squared plus 0.6 t for 0 until 4 second. Find the velocity of x at t equal to 4. So already we have understood that this question belongs to kinematics, and for kinematics they have already given the expression of s. Okay, so we can write s is equal to zero point 0.3 t square, 0.3 t square plus 0.6 t. Well, and they have told us to find the velocity, and for velocity, integration of displacement is velocity. So let us find the derivative of s. Derivative of s in term of t is equal to the exponent will multiply the coefficient, it is going to be zero point 0.6, and degree will decrease by 1, plus it was 0.6 t. So if we multiply zero point 0.6 by 1, 0.6 times 1 is actually zero point 0.6. So zero point 0.6, and t, the degree of t will be 0. So they have told us to find the value of t is 4. Let us write, or v is equal to point, I mean, instead of t we are going to substitute 4. Time is 4 seconds, so zero point 0.6 into 4 plus zero point 0.6. Hence our velocity when t is 4 is equal to 24 plus 6, that means 30, and it is actually 3 meter, 3.0 meter per second. That is what the velocity when t is 4. And the immediate next question says, for t is greater than 4, the acceleration of x at time t second after leaving O is a meter per second square, where a is equal to zero point 3 t raised to half. There is no change in the velocity of x at t is equal to 4. The velocity of x at t is equal to t, uppercase t, is 14.2 meter per second. Find the value of t. They have told us to find the value of t. So in this part of the question, they have given us acceleration, and from acceleration we'll have to turn back to velocity. And if we turn back from acceleration to velocity, we'll have to integrate the expression. So let us write, for t is greater than 4, acceleration is given zero point 0.3 into t raised to half. Okay, now if we want to go back to velocity, look at this, they have told us to find the velocity is given, so we'll have to turn back to velocity. For velocity we'll have to integrate the acceleration, or if we integrate acceleration, let me write, a in term of second or time is equal to, so in acceleration degree is increased by 1. If we add up 1 to half, it is going to be 3 over 2, so it is zero point 0.3 into 2 over 3, and it is, the power is going to increase by 1, so it is 3 over 2. and we should not forget the constant value. There may be constant value at the beginning of this phase. So it is going to be integration of acceleration, it is velocity. V is equal to, if we divide zero point 0.6 by 2, it is zero point 0.2 actually. 0.2 t raised to 3 over 2 plus c. Now this phase starts from 4 second. Look at this. So at 4 second, what was the velocity we'll have to write? Let us see, at 4th second velocity was 3. So these 3 must be added as constant number. So please don't get confused with this. There we have started, our phase has started from 4 second. Okay, so we will have to write what was the velocity at 4 second. These velocity is after 4 seconds. So but when the starting velocity must be, initial velocity must be written. So in integration, we must not forget to add up the initial velocity, initial value. So we will have to write t is equal to 4 when v was 3 meter per second. Then if we substitute v, it is going to be 0.2 t 3 raised to 2 plus c is equal to 3. Now if we simplify this, it is going to be, our v was, I mean t was 4, so 0.2, if t is 4, 4 can be written as 2 square, so 2 square into 3 over 2 plus c is equal to 3, or our c is going to be 3 minus what is going to be over here. So 2 cube means 8. 8 2s are 16. That means 1.6. Hence our constant value when this phase starts, the constant value velocity was 1.4. Hence we can write our velocity v is equal to what? The expression should be 0.2 t raised to 3 over 2 plus 1.4. So this is the complete expression for velocity when the time is more than 4 seconds. Well, then actually we are going to find, they have told us to find the t, that is time when the velocity was 14.2 meter per second. So we are going to find over here, let me write just beside this. They have told that velocity is equal to v is equal to what? 14.2. 14.2. So let us see what is the time when velocity was 14.2. Our expression is 0.2 t raised to 3 over 2, 3 over 2 plus 1.4. 1.4 is equal to 14.2. So our t is supposed to be obtained. Okay, so 0.2 t raised to 3 over 2. Then if we subtract 14 from 142, it is going to be 128. That means 12.8. Okay, or if we divide this 12.8 by 2, that is 64. That means 6.4. No, not 6. Yes, it will be 64, not 6.4, because decimal point can be dissolved. So t raised to 3 over 2 is equal to, if we divide it by 2, it is 64. 64. Okay, then we can transpose this to the other side. It is going to be 64 square means actually 4 cube, and if we transpose this exponent from the left side, it is going to be 2 over 3. 2 over 3. Hence our t has become, look at this, if this 3 dissolves another 3, that remains square. 4 square means 16. Hence our uppercase t is equal to 16 second. That means at the time of 16 second, the velocity was 14.2 meter per second. 16 seconds. Okay. And that's the final answer to this part of the solution. So we have solved the first two part of this solution. These are not difficult at all. I think you yourself can also solve this. So let's move on to the next question. The next question is on the next page. It says that find the total distance traveled by x between t is equal to 0 and t equal to t. So if we observe the question looking at the graph, also graph is not unnecessary, it's not necessary to be written here, that's why I'm not drawing the graph, but we can see that this acceleration or velocity graph was not uniform. Look at this. For for 0 until 4 seconds, there was the nature of the graph was something different. That's why we will have to find s is equal to, it is already given from the previous page, you can copy. What is it? It's zero point 0.3 t square plus 0.6 t. So 0.3 t square point 3 t square, and our t is time is actually what, 4 seconds. So 4 square plus zero point 0.6 t. So zero point 0.6 into t, t is 4 second. Okay. So it is going to be 16, 3 16s are 48. So 48 and it is 224. So 72. That means 7.2 meters. So for the first phase, the displacement in 4 seconds, the particle traveled 7.2 meters. Now for the second phase. For the second phase was starting from 4 until 16 second. They have told to find t, t was actually 16. The value of t was 16 second. Okay. For 4 until 16 seconds, our velocity is known to us. Okay. V is equal to what? Just we have written on the next page. It was, V was this. The expression was 0.2 t raised to 3.2 3 raised to 3 over 2 plus 1.4. So let's copy this. If we write here, V is equal to 0.2 t raised to 4 over, sorry, 3 over 2, 3 over 2 plus 1.4 plus 1.4. Now we require displacement. If we go back from velocity to displacement, we'll have to integrate this. So let us integrate. How long? It is definite integration from 4 until 16 seconds. In terms of time, if we integrate this, it is going to be 0.2, then t from t is, sorry, not t, it is t raised to 3 over, no, we should integrate this, sorry, I'm not integrating. So integration power is increased by 1, so it is 1.5 plus 1, that is 5 over 2. So if we write here 2 over 5, and the exponent of t will increase by 1, that is 5 over 2, and the limit is from 4 until 16 second plus 1.4. If we integrate this, it will be t t, and the limit is 4 until 16 second. And please don't get confused with this. In the previous case we have added constant number. Why am I not adding constant number? Let me explain. If I explain briefly, it is actually very simple to understand. Look at this. We are finding the displacement starting from 4 until 16. Already we have found the constant value when t is 4. Displacement has already been obtained, which is 7.2. So there is no necessity. We are including 4 after 4th second. Okay, that's why at 4th second, what was the displacement is what the displacement is necessary for us. Already we have calculated that one. We are not including 4th second. Remember, it is more than 4. That's why here constant value is not necessary. We don't need the value of displacement at 4th second. At 4th second it is not included. We have start, it is beginning of from 4th second. That's why constant number is not necessary to be written over here. Let us write, it is going to be s2 second phase, and 2 twos are 4. If we divide 4 by 5, it is zero point 0.8, so 0.08. And t is actually, the upper limit is what, 16. 16 can be written as 4 square, so 4 square into 5 over 2, 5 over 2, 5 over 2 minus, lower limit is 4. 4 can be written as 2 squared, so 2 square into 5 over 2. Then for the second quantity, it is written 1.4. Okay, 1.4, 1.4 into plus 1.4. If we subtract 4 from 16, it is just 12. Hence our second displacement in the second phase is, it is going to be 2 will be dissolved, so 4 raised to 5, 4 raised to 5, and 4 raised to 5 minus, let us use our calculator. It will show 4 raised to 5 minus 2 raised to 5 means 32. So if we can use our calculator directly. Let me cancel these two, and this two. So it is 0.08 into 4 raised to 5 minus 2 raised to 5 plus 1.4 into 12. So it is going to be, first quantity is 79.36 plus 14 to 12 168, that means 16.8. If we add up these two quantities, it is going to be 79 and 16, so it is going to 95, so 96.16, 36 is 16. So this is the distance traveled by the particle in the second phase from 4th second until, starting from 4th second to 16th second. Now they have told us to find the total distance. If we sum up this, both the distances or displacements, we will get the total displacement. Hence total displacement, total distance or displacement, whatever you write, total distance is equal to, first phase was 7.2 meters, 7.2, 7.2 plus, in the second phase it was 96.16 meters, equal to, if we write here meter, then 96 is 103, 103 plus 36, so 103.36 means we can write 4 if we round it up to 3 significant figures, I mean 1 decimal point. So 103.4 meter is the total displacement. Finally, I can tell that this is the question which is based on kinematics, and there is nothing complicated here. I believe that you yourselves are very confident and knowledgeable to solve this yourself. So let me show the previous one. This is what the previous one. There is a little twist in question number B. Otherwise, it's a very simple, one of the simplest and easiest questions. So thank you all for being with me, and may Allah bless all of the human beings with beneficial knowledge. Fi amanillah.